Okay, students, say we're back again. This is going to be our last section of this webcast, this last webcast series for our lectures in Module 2. So last time we talked about mining and how we get our mineral resources and how we extract them from the ground and use them, and some of the environmental aspects of it. We'll get a lot more of that in your reading a little bit, and then we'll talk more about it later. But this time we're going to start talking about, well, where are these minerals actually located, and then also going on to talk about rocks, okay, a little bit, and introducing the rocks, and we'll talk about those different rock sections in our next coming weeks. Okay, so one way that we also look at rocks and minerals, or ways that we find them, is through the way that they're formed, right? So, for example, if I want to find gold, I want to find a place that used to be volcanic in nature, because gold is a dense material and it usually forms in volcanic surroundings. So I'm not going to go to a place off the coast of in our coastal plain of North Carolina, because the coastal plain of North Carolina is we call a passive margin and has no volcanics, right? However, a long time ago it did have volcanics, and so I can go up into the Piedmont of North Carolina and find old volcanic areas to find gold at. Now, I could also go look for gold in California, where they have old volcanic centers there. Utah, Idaho, all that region where we can find gold in those areas, Nevada, Arizona, are all places we can find gold, because they're all places where we have old volcanic activity. If we can also go maybe up to the Cascades. One of our students is from the Cascades, if I remember right, that region at least. And we could find gold there, but those are active volcanic activities. Those are places where we have an active slab of oceanic crust going down and they're forming there. Now, I probably wouldn't be mining the volcanoes quite yet, because they haven't cooled off and the material is still rising and actually forming. So I want old volcanic activity. So we can look at plate tectonics, though, and to try to find out where those materials were in the past to be able to understand where we can mine in the future. Okay, for example, in places where we have oceanic deposits, we can find chromium, platinum, copper, and zinc. In places where we have hydrothermal veins, like we were just talking about, we can get gold and silver and copper and lead and things like that. And it's places where we have sedimentary deposits. That means when rocks have been broken down into smaller pieces, we can have things like coal and oil and shale. We'll talk more about that later. But the point comes is there's different minerals and different rocks in different parts of the world because of how the earth moves and migrates, how mountains are built and volcanoes grow, earthquakes, and all that. Now, plate tectonics is going to be a big topic that we talk about later, but I want you guys to understand that that's one of the reasons we know where we have the materials we see today. Okay, so now we're going to start into the rock cycle. The rock cycle is basically how rocks change over time. Now, a rock, we've already kind of described this. It's basically a naturally forming consolidated material composed of one or more minerals. And we've already talked about what minerals are. So remember, this rock right here, this is actually a granite from Mount Rushmore. It's actually from Crazy Horse, which is just down the street from Mount Rushmore. But it's a granite, and it has these black minerals here, which are what I call tourmalines, which are this guy right here. Or it could be the white kind of guys right here, which is like this quartz that we have here. There you go. Okay, and so there's lots of different minerals beside this that we can actually extract. But this rock is what we call an igneous rock. It's one of the three major types of rocks. And igneous rocks are basically formed when magma or lava in the Earth's interior cools in or on the crust. Now if it cools inside the crust, we call it magma. If it's molten inside the crust, we call it magma. And if it's molten on the crust or on the surface, we call it lava. But if that molten material cools off, it would be a rock like this, which would be an igneous rock. Okay, and so at one point it was a liquid or molten material that has then been solidified. Right? Okay. So now then there's other rocks, and let me pause for a second so I can get some samples. Oops. Okay, so we just did igneous rocks, but there's other kinds of rocks as well. And so the next one is what we call a sedimentary rock. Now, a sedimentary rock is basically other pieces of rocks that have been broken down because of weathering. Okay, so they're formed from igneous rocks, or the other type of rock we call metamorphic rocks, or other sedimentary rocks that have been broken down into small pieces. So, for example, on this one right here, you'll see lots of little small rounded pieces that have been broken down maybe from a river or a beach or something like that. slowly over time, and then cemented back together or consolidated back together. So this rock was actually always in its solid form. It went from its process of being broken down to the process of actually being cemented together, always been in solid form. Whereas this one, the igneous rock, was once molten in a liquid form and then became solid, right? So there's differences between those. The last one is what we call a metamorphic rock, and this rock has been altered because of heat and pressure, and it's caused by basically the pushing of plates and stuff like that during plate tectonics or heat from the magma below to actually form these different rocks. So this is an igneous rock. I mean, sorry, not an igneous rock, a metamorphic rock. And it has different minerals inside of it. Let me see here, that you can see that it actually forms only underneath heat and pressure. And so this rock here was never in a liquid form. Okay, so this rock formed from the altering of sedimentary or igneous rocks, okay, by means of pressure or heat. So it basically was never, if it was melted all the way and then cooled off, there would then be an igneous rock, right? So this one has been pressurized or heated enough where the rock itself was become what we call plastic or ductile, okay? So like this piece of plastic that I have here where it can bend, right? That would be called something that would be ductile, okay? And so minerals and rocks that are underneath a lot of heat and pressure can start to bend and actually move and form what we call, and reform into what we call a metamorphic rock. Okay, so that's an example of a metamorphic rock. Now, remember, a rock is that coherent. I'm just going to go through this definition real quick because we've already done it really. Coherent, which is held together as a solid mass. It's naturally occurring. It's an aggregate of mineral grains or glass. Okay, so an aggregate of mineral of different rocks like this would be a conglomerate. It's a type of sedimentary rock. Or you can get a granite here, which has different minerals that have cooled off to form a rock, right? Okay? There's two different types of these mineral grains. One of them could be what we call the clastic ones, where the broken down pieces of grains are held together by cement, like my conglomerate that I just showed you here. Okay? So each of the individual grains here was broken down somehow and cemented together. Okay? That's what we call a clastic rock. Clast means particle, by the way. Okay? Then a crystalline rock is like my granite that I just showed you here. Okay? With all the different individual mineral grains in it. Okay? And this formed because of crystallization from a melt at some point. Okay? So rocks are grains that grew to interlock with one another is what I call a crystal rock. So all metamorphic rocks and all igneous rocks are what we call crystalline rocks, where all sedimentary rocks tend to be most sedimentary rocks tend to be clastic. Okay, so now, and I want to talk about that because our next section is going to be about sedimentary rocks. That's the first section we're going to be talking about there. Now, when we go around in this neighborhood, we can actually find bedrock on occasion. We'd have to kind of search for it here. If you live somewhere else around the world, it's going to be a little easier to find bedrock. But we're in a place that has lots of sediments, the broken down pieces that have been shed off the Appalachians and now are being deposited in the coast or coastal plain that we have here in Pembroke. So bedrock is basically that rock at the surface of the earth that's still attached to the earth's crust below. Okay, so if I go down the road to go to Rockingham, I can find some granite, and in that granite, it actually, if I dug down, it would still be solid rock all the way down, right? Whereas if I dug down right here in Pembroke, it's going to be this just a bunch of sand, and I'd have to dig down about 800 feet, probably a little less than that, probably about 600 feet before I got to solid rock. And that solid rock is what we call bedrock. The stuff before that is just our overcover, or unconsolidated sediments. Okay, and an outcrop is just a surface exposure of that bedrock. So if I drive down the road and I drive through what we call an outcrop, where we've cut through just to drive through that section, there might be some solid rock in there, and that's what we call an outcrop. So this is an example of some outcrop in Arizona here. We have the bedrock layered here, and then on top of it you have this partially covered material or sedimentary deposits. So that rock cycle is that cycle of how the material actually changes over time. So you might have your magma here that cools off, and as it cools off, it might form into this igneous rock. And if it's on the subsurface, we might get things like this granite here, right? Or if it's cooled off on the surface, we might get lava rocks like basalt or something like that. Okay. Well, if that material is now exposed to the atmosphere or into water, it can start to weather or break down. Okay, it will start to weather and break down, and then get transported, then maybe even to be deposited somewhere, and then we call these materials sediments, things that have broken down and actually been transported over time. Now those sediments can then be lithified or made into a rock. Lith means rock, and fication means to make. Okay, so lithification is to make a rock, usually by compaction or cementation. And then we form what we call a sedimentary rock, like this conglomerate I just showed you just a second ago. Now if that sedimentary rock went underneath lots of heat and pressure, it then might become a metamorphic rock, right? And if it went under enough heat, it might then melt, become a magma, and then cool off again and become an igneous rock. Okay, so that's what we call the rock cycle. Now that could change in the time frame. Instead of coming from a extrusive, or a rock that came out of as a lava, maybe it just came from the inside, and that granite then was weathered instead of that basalt, right? And then it went through that process. Or maybe a metamorphic rock got exposed to the surface, and then it went through that same process. Or maybe a sedimentary rock got exposed to the surface, and then it went through that same process, right? So it does not have to be in this circle. We could actually skip steps. Okay. So for example, let's say get an igneous rock, and instead of going to becoming a sedimentary rock, first it went straight to becoming a metamorphic rock. Okay. So those are things that understand there's different links between this cycle. Okay. So we're going to go through and talk about these different rocks in three separate groups. We're going to first start off, we're going to do igneous rocks, which is part of talking about how magma crystallizes into two different types of rock: an intrusive rock, which goes underground through crystallization, and then an extrusive rock. Okay, which is, here we have our magmas and our lavas. Okay. Formed by consolidation. So those are your igneous rocks. Okay. Now, sedimentary rocks, this section we're going to be talking about next, or next week, or the talk about when we get igneous rocks or metamorphic water or whatever, and they weather the material, then transport it, deposit it, make it into sediments, lithify it to form your sedimentary rock. That's the next, what we call the sedimentary rock cycle. Okay, portion of the cycle. The last one is your metamorphic one, where it's caused by heat and pressure. And that's the last one we're going to be talking about. That's like our fourth week, if I remember right. Okay, and then we'll be done with our rocks section. Okay. Now I do want you to understand that we mine every single part of the rock cycle as well. So sometimes we don't want just the mineral. We just don't want, like this is some of the minerals here might be like here over here, where you have your gold, your pyrite, stuff like that. We might not just want just the salt. We might want the granite for our granite countertops, right? Or we might want pumice for abrasion skulls. We might want obsidian. We might want asbestos right here, which is a mineral. We might want bauxite. We can get aluminum from. So we don't only just mine the minerals, but we sometimes also mine the rocks for their special properties as well. Okay, guys, that's all we have for this week's lecture series. If you have any questions, please put it either in the common discussion board or shoot me an email, or even you can talk about it in our discussion board this week. Okay, guys, thanks a lot.